Here we go. Last section in 5.5. So after this, you will have everything that you need for 5.5, and you guys can start preparing and prepping for the exam. So 5.5, we pretty much already have done. It's going back to what we did with the quadratics and when we had inequalities, and we're going to be finding when are we above the x-axis, when are we below. I mean, we've done this, and again, we talked about this in the also in the rational section in 5.4, where they asked that weird question, hey, when is your rational above the x-axis, when is it below the x-axis? That's what's going on. So we're going to do this two ways. We're going to do it where you look at pictures, and then we're going to do it where I give you the equations. Okay, and all those techniques that we did in the section when we did quadratic inequalities, about finding those critical values and doing some test points and seeing whether it's positive or negative, that's the same thing we're going to do here. Just this time we have larger polynomials and we have rationals. So, I mean, this section, it's all old stuff, but we're just giving you a different inequality, like polynomials and rationals. So again, when you're answering these, they want them in interval, okay? And you will be using unions because you're going to be talking about solutions, okay? So do not put commas between your intervals. You want to use unions. So now, in here, first things first. This guy right here says you want to be greater than 0. As long as our function is set to greater than or equal to 0, less than or equal to 0, things like that, we're good to go. If it is not 0 over here, you want to do some fixing, okay? And we'll have a problem that's like that. So I've drawn in the line here that represents our x-axis, and all these questions are asking whether you're above or you're below. Greater than is above, less than is below. Now make sure that you pay attention to the symbols, because the symbols are going to tell you whether you want to use brackets or parentheses. Okay, so remember that if it's the greater than symbols or the less than symbols, just those, we want to use those parentheses. When it's less than or equal to, greater than or equal to, make sure that you use those brackets, okay? So for A, we want to know when we are above the x-axis. So I come in here, we want to know the interval for that hump and for that right there. Now remember, that's an arrow, so it's going to keep going on and on and on. So what's the interval for this hump? Remember, this is all about x values. So it starts at 0 and it ends at 1. So are we going to have brackets or parentheses? Well, because we want to be greater than 0, that means we don't like the points that are on the x-axis for those. So that means we are going to use parentheses, just as I talked about there. When we look at this guy, where does it start? It starts at 2. And then where does it go? It shoots off to infinity. Okay? And again, the 2, do we like the 2? No, we don't, because we want to be greater than 0. So it's a parenthesis, and infinities always get parentheses, and then there's a union between it. That, my friends, is the answer to part A. Go ahead, pause this, try part B. Okay, so here we want to be less than or equal to 0. So here we want to be all this piece of the graph that is downward, below, excuse me, my green x-axis. All right, so we've got this piece of graph that's right here. Where does it start? It starts at that arrow, which is negative infinity. Where does it end? It ends at 0. Now, infinities always get parentheses, but what about the 0? Do we like being a part of the x-axis there? And we do, because we're equal to. So since we're equal to, we want a bracket for that guy. All right? So then we look at the next interval, which is right here. Where does it start? At 1. Where does it end? At 2. 1, 2. And do we like being a part of the x-axis again? Absolutely, because we are equal to. And then instead of a comma, put a U between them. And there's the answer to part B. That's what this whole section is about right here. That's all you've got to do. Okay? So let's take a look at, yes, my daughter's yelling no, so I just yelled yes. So let's look at a rational. So f of x was a rational in this. Okay? So part A says we want to be greater than 0. So again, this is all. I like that we're equal to 0. That makes things a whole heck of a lot easier for us. So there's our dividing line. So in part A, it wants to know, when are we above the axis? Okay, when are we above my blue line? Well, I'm going to highlight my graph for you. So right here, we are definitely above, from there to there. Okay, we're definitely above, starting right here to here. And then we're definitely above from here on over. Okay, so let's start writing our intervals for this. So we start right here at this arrow, and that's the negative infinity side. And we're going to go all the way up to this dotted line. Okay, because that's where, this piece stops, because these two aren't connected there. So that dotted line, and just like and we've done this before, when we were back in section 5.4, we did this because we wanted to know when are we above the x-axis at -1. Now, do we like -1? Okay, well, partly in here, you can look at this. We want to be strictly above 0, but the other thing is this -1, remember, that's an asymptote. Asymptotes always have parentheses, no matter what the symbol says. Asymptotes always have parentheses. Okay? So this guy is a parenthesis, and this guy is a parenthesis, because infinities always get parentheses, and the -1 is an asymptote. When else? Okay, so we're above the x-axis right here on that little blue line. So when did that start? It picked up on the other side of the -1. And when did it stop? It stopped at the +1, which is an x-intercept. Okay? So again, we already know that the asymptote gets a parenthesis, but do we like the 1? So x-intercepts, when you're dealing with this with the rational, you have to look at the inequality sign. And that will tell you whether you are a bracket or a parenthesis. So if we look at our inequality sign here, there is no equal to, so that 1 is a parenthesis. And again, there's a union between there. So we got one more piece of our graph that is up above. It's right here. When does it start? It starts at 3. When does it end? It shoots on towards positive infinity. So infinity is always parenthesis. Again, that 3, that is an x-intercept. Okay? But we yield to the inequality sign. And since it is just greater than, not equal to, it is also a parenthesis union. So that is the answer for when we are greater than 0. Okay? Now let's focus in on the next piece. So here we want to be less than or equal to 0. So when is our graph below my blue x-axis? So here I'm highlighting all that for you. All we got to do is write those intervals out. Okay? So my first piece of purple line starts right here at 1. And where does it go? It goes towards this asymptote, which is 2. So because 1 is an x-intercept, we revert to the sign. So it's equal to, so that's going to be a bracket. Okay? Then it's an asymptote, and I already told you asymptotes are always parentheses. So there's how that interval looks. And now we look at the last interval. Well, it picks up on the other side of 2. And it goes up to the x-intercept 3. Okay? So since 2 is an asymptote, parenthesis, Since 3 is an intercept, we revert to the sign. The sign is equal to, so it's a bracket. And there is the answer for that. So in your assignment, you'll have 2 of these that start out. One it will be a polynomial, where you'll find the intervals, and the other one will be a rational. And then in the end, I think there's only 4 problems total. They're going to give you 2 equations. So let's go ahead and tackle the equations. You notice this one's not equal to 0, so that means we're going to have to do some fixing on this, and we'll talk about that one soon enough. This is as hard as what these problems get, and definitely make sure that you pay attention to this problem because you might see this later on in the test. Okay? So, solving inequalities. This is just like what we did with the quadratic inequalities, okay? So the first thing you did with the quadratic inequalities is you had to find those critical values, okay? When it comes to the polynomials, you're going to be looking for those x-intercepts, all right? When it comes to the polynomials, you're going to be looking for those x-intercepts. When it comes to the rationals, you want all the other information. So when it comes to the rationals, we want to know all this information, the vertical asymptotes, the x-intercepts, the domain values that are excluded. Remember, hopefully the vertical asymptotes and the domains match up. Okay? Hopefully the vertical asymptotes and the domains match up. If they don't match, then that means you have a hole. But I'll give you a hint. They should match up in here, so we shouldn't have to worry about any holes. If you have a question about holes, email me, call me, text me. We can talk about that to our leisure, okay? But for our assignment, there should be no holes. Hint, hint. Okay. So once we have that, remember that we set up test values around it, and we are just looking for the positive and negative answers. And from there, we know what our intervals are doing then, okay? Just like what we did with the quadratic intervals. So let's get started. So in here, the big thing for you is you're going to have to factor this. I promise you they're going to give you something that you're going to have to factor. And the cool thing about this one is in whatever we give you, it should be pretty easy to factor. So when you're looking at this, the first thing that we want to do in order to factor this, because we want the factored form to find those x-intercepts, because that's all we're looking for is the x-intercepts, because this is a polynomial. And we're equal to 0, so that's a good thing. So to factor this, let's go ahead and pull out an x squared because that's what's in common. It's a GCF. That will leave you with x minus 4. And of course, greater than 0. And now that we have this factored, we can figure out what our x-intercepts are. Because all we're going to do is set those factored pieces equal to 0. So x squared equals 0 and x minus 4 equals 0. So here, for this first guy, you'll take a square root. Square root. X is equal. Technically, it should be plus or minus 0. But because 0 is neither positive nor negative, we just drop it. So x is equal to 0. Over here, x is equal to a positive 4 because you add 4 to both sides. So now that we have the x-intercepts, these are going to be what help us with the test intervals. So we've got a 0, we got 4. So we need to choose a value that is less than 0. -1, good choice. A value between 0 and 4, I choose 1. Yeah, that's a good choice too. I like 1. And a value that's bigger than 4. I want number 5. Good, Satan, we'll go with number 5. Okay. So from here, again, all we're going to do is we're going to plug it in to our original equation up here and see if the value is positive or negative. So you just break out your calculator, and I'm going to plug in -1. We're going to cube it, -4, and a -1. Hit enter, and that answer is positive. And I'm trying to write with an eraser. Then we'll go back. I'm just going to go up. I'm just doing this on my calculator because you guys know how to plug stuff in. I just re-grabbed my equation I wrote, and all I'm doing is going back in and deleting out the negatives. And so I got 1 cubed minus 4 times 1. And that answer is negative. And then now I'm going to go to the 4. Okay. and I'm going to plug in the 5. So again, I'm just going to go up, grab the equation I had, plug in the 5, and I get a positive. Okay? So there is what we know about our polynomial. Okay? So looking at this information, now we can answer our question. It says in our question, well, we want to know when we are greater, quit moving, greater than 0. So that means we want to be positive for our answers. Okay? So when does that happen? Well, we have positive answer right here and a positive answer right there. So what are those intervals? Well, this interval happens from negative infinity because it's all below 0, all the way up to 0. And this interval starts at 4 and goes off towards positive infinity. Do not worry about these numbers up top. They were just tests. They don't matter. So this one goes from 4 all the way up to positive infinity. Okay, well, we know infinities are parentheses, but the question is, are these supposed to be brackets or parentheses? Well, we go up and we look at our sign. Our sign is greater than, so greater than symbol, because we're not equal to, are always parentheses. And put a union between that, and that is the answer. Okay? Any questions about what we have there? All right. One more problem. So we have x plus 2 all over x minus 4, and we're greater than or equal to 1. So because we are greater than or equal to 1, you got to be careful in this one. So let's do this one together instead of pausing the video and trying it on your own. So we got to move this 1 to the other side. So we're going to subtract it. And what that gives you is this. X plus 2 over x minus 4 minus 1 greater than or equal to 0. Now that we got that greater than or equal to 0 part, that's good. But the problem is I've got this minus 1 over here I got to deal with. You got to go back to your intermediate algebra skills, and we've got to add these two rationals together. So remember, in order to add fractions, you got to have a common denominator. So the common denominator between these two is going to be really easy. Whatever the original denominator up here was, that's what we got to put over here. And because it's the number 1, that makes it easy, because what this second rational has to look like, because it has to have the common denominator, and we know it's got to be x minus 4, the top will also be x minus 4. Okay? Because x minus 4 over x minus 4 is still 1. All right? I promise you this is how the problem will work. Okay? So again, though, if we really want to talk about what's going on, you've got x plus 2 over x minus 4 minus 1 over 1. The common denominator has to be x minus 4. So in order to turn this into an x minus 4, what did I have to do? I have to multiply it by x minus 4. And if I multiply the denominator by x minus 4, I have to multiply the numerator by x minus 4. Hence, we get the x minus 4 over the x minus 4. This guy is still x plus 2 because it already matches. Okay? So that's really what's going on. So now let's put these two together. So remember, when you add fractions, all you do is you add across the numerator and you're putting like terms together. But you got to be careful because of the minus, because the minus affects all of that. So what that numerator really looks like is x plus 2 minus parenthesis x minus 4, because that minus is affecting all of that right there. So if we really take care of that minus now, we have x plus 2 minus x minus 4 all over x minus 4, greater than or equal to 0. And now combine like terms, so the x's get together and cancel each other out. The 2 and the negative 4 get together and give you negative 2 over x minus 4. This is what we are going to be concerned with now. This is what we want to find the x-intercepts and the vertical asymptotes to, and the domain. Okay? So you can see that in here, if you look at the domain, you just set the denominator equal to 0, so x minus 4 equals 0. So in the domain, we are throwing out the number 4. So the domain of this, x is not equal to 4. There's no simplifying or reducing. There's nothing to factor. And again, in the problem that you'll have, there will be nothing to factor. So in order to find the x-intercepts, remember the x-intercepts, all you do is you set the numerator equal to 0. Well, but if I take and set the numerator equal to 0, so this guy was the domain. So the x-intercepts, if I set the numerator equal to 0, it doesn't make any sense. Negative 2 equal to 0. So that doesn't make any sense. So that means there are no x-intercepts if it doesn't make any sense. Okay? And then last but not least, find the vertical asymptote. To find the vertical asymptote, all you do is you set the denominator equal to 0 on the simplified rational. But again, this is already simplified. So you're just kind of doing the same thing again, just like what we did with the domain. X minus 4 equals 0. So x is equal to a positive 4. There's your vertical asymptote. So now you have all the numbers that we need in order to set up our intervals. So all we want to know about is, excuse me, is what's happening around 4. That's the only number we had. So I need a number below 4. I choose 0. Good. I like that, Mr. Ogre. And then I need a number above 4. I choose 5. Thanks, Mr. Mouse. Okay. So all we're going to do is plug those into our calculator, and we're plugging it into this equation that we're working with right here. This is the guy you plug into. Don't go back to the original. This is the one we want. Okay. So we're going to plug in 0. So alpha y equals, we're going to put that negative 2 on top, and we've got 0 minus 4 on bottom. So that gives you a positive answer. Over here with the 5, I'm just going to grab what I just did, and all I'm going to do is replace that 0 with a 5. And that gives us a negative answer. Okay? So now we can answer the question. The question says, on our new equation, not the old one, when are we greater than 0? Greater than or equal to 0. So that means, again, we want positive numbers. So when are we positive? Right here. So this interval that from in here is negative infinity all the way up to 4. Well, we know infinities get parentheses. This number 4, remember from earlier, this is an asymptote. Okay? In fact, it's a vertical asymptote. And what do we know about vertical asymptotes? They're always parentheses. Even though our sign said equal is an equal to, because it's a vertical asymptote, we don't include it. And that is the answer that they want. That's as hard as what this gets. You just find that information, you set up your intervals, and you're just looking at the signs. And that, my friends, is 5.5, and that concludes Module 4. Thanks.